Hello everyone and welcome to Tekkit. I hope you're interested in computers, because if you're not, you're at a wrong place, because I am going to build stuff using the Redpower computers in Tekkit. I could use computer craft, I guess, but I kind of like the Redpower computers because they're quite powerful for just a mod actually. Let me show you how this works. Basically what I'm going to do here is not do basic computer stuff. I am going to link up multiple computers, Redpower computers, to form a network. Yeah. Well, there's multiple ways I could do that. Maybe. I have thought of one. I'll try to execute it, and it's going to take some time, I think. So, no, one thing first, we are very limited by this thing right here. This here is the central processing unit of the Redpower computer, along with the monitor, which goes at the top, and the disk drive. Three main parts. Put a floppy in there. Central processor. Central processing unit is a processor, I guess. It's also the rest of the computer. There's no motherboard and such, but this kind of functions as all that. And there's the monitor, which is used for input and output. You can use an I/O expander also to increase your range of input and output with redstone signals. There's a thing at the back, so I kind of placed this thing wrong, where you can attach this, which is a bundled cable, where there's multiple coated cables that you can. So let me get a wire. These colored wires. They go in there, and you can take them all out apart. And with the I/O expander, you can turn them all on and off individually. So that's cool. I'm gonna use this to link up two computers. Yeah, that's what I'm going to do. So the computer, central processing unit, feeds into this, then redstone signal into the wire, goes at the back, and voila, they send signals to each other. You can look at the input, you can send output, basic stuff. Okay, so as I was saying, I kind of forgot about that, but we're limited by this device, which is, oh, there's also a ribbon cable, by the way, which goes in the, get to that later. I'm very easily distracted. So, the processor, central processing unit, we are very limited by this device. It's basically a single core processor, so you can make it do one thing at one time. No multitasking, nothing like that. Okay. So it's a shame, but understandable. The beauty of it is that it actually houses a real processor structure. So I can use assembly language to talk to it. I'm not going to, by the way, but I could use assembly to talk to it directly. Which is the beauty to it, because it's real. It's a computer simulated in my computer, in a game. There's not too much fiction about this thing because it's actually very real. So I have taken a couple of limitations away. We've got this device and the disk drive, where we are going to put a floppy in. This is a blank one. No, this is a boot floppy. This is a blank floppy. And the default language to program in the Redpower computers is Forth, which is a stack-based operating system. Well, it's not an operating system, that's the point. It's a stack-based programming language, programming environment, which I'm not going to use because I find it very confusing, which is basically my own fault. Then I could use assembly, which indirectly we are going to use because we are going to talk to a processor. You can only talk to processor with assembly, which is machine language kind of stuff. Like put this in that register. Well, very complicated. I can do it, but basic sorting algorithm is basically the best I can do about that. And then there's basic, and most of you will have heard of basic, or if you have any knowledge of programming, you will have programmed in basic, I think. Even if you've just been on your calculator and programmed a little script, that's basic. Most calculators with that functionality. Graphical calculators use some form of basic. I'm spending all kinds of time just explaining this shit, and it's getting pretty boring, so let's boot it up. I'll link to a tutorial in the description of how to get basic onto your Redpower computer. I ballsed it up a bit, and you see this is the 4th boot disk, which is the normal programming language to use with these things, but somehow I have overridden that and gotten my basic, MS Basic boot disk on there, which actually isn't that bad, because I'm not going to use 4th, and when I go to boot, not these kind of boot, this boot disk, it will automatically be the right thing. So let's see, it doesn't need power or anything, which is nice. Okay, well, I could use this later on, but now I'm gonna start it, and we're gonna look at the screen. We go, Mine OS version 1.1 initialized 600 bytes free. Actually, what I'm going to do is extend the RAM memory for a bit, like this. Back plane, back plane, and an 8K RAM module. If I want to add more, I've got to build it elsewhere, because it works like this. Like this. But you can only put these things at the back, not at the side, nothing, just at the back. But I'm not going to use that, I hope, because I not have enough space in my server room right here. Let's start off with the network that I'm going to build. I'm not quite sure how I'm going to do it. Not entirely sure what to say. I think what I'm going to do is use a central server, which is like a DNS server. So this server knows when he gets a signal. It knows where to send the signal. So we've got a computer right here. It says, hey, do this, and it sends it to that, because this is A, B, and A wants to talk to B, and this thing here, which is, let's call it main or something, M. This is M. I like that. This is M. A wants to talk to B, so it says M, send this message to A, because A is a name, but it isn't there, and what was I saying? So A is just a name, but it also has an address of some sort. It's got to have an address, which I've got a basic idea of how I'm going to do. That'll be later. So A sends to M message A M B M. If B wants to send a message back, it goes B M A. Could do it in another way, but that way you would always, every computer would need to know every address of every other computer, which is also, a security problem when you're working with I'm off on a tangent here, but when you're working with computer security, you've got keys to distribute, and how do you do that? Does everyone have to know everyone else's key, or is there one person who knows all keys and you can communicate through him? Do you trust that person? Well, this is my own server, I'm going to trust it. The applications of this are also, of course, a thing. Why am I doing this? I've got a compound up here. Well, it's 2 houses. I'm going to extend it. Maybe I'll show you another time. So what you can do is basically build one device like this. Okay, it's got to be like this. No, not that. This. Okay, and I tell him. I can tell him everything. And basically, there's this things scattered all over the compound. There's an automated farm. There's all kinds of stuff, and I want to be able to talk to every single one of them through my PC. I could do that just by running a cable like this. This, look, that's where you attach it. This at the back. This, and it'll have to go to this, and then also here, and just extend it to here, and there's a CPU there. Look, like that. But as the number increases, this gets incredibly inconvenient, especially with the addresses, because they will, you know, this thing, this, I'm gonna call it a terminal, would have to know every other address, because in order to talk to the farm, you've got to need the address of the farm, and to talk to the quarry, you have to know the address of the quarry. Well, I can just build a server that has a single purpose to route all messages. Okay, right. That one, my sister leaving. Shouting around the house. Okay, so I was saying there's a single purpose server. They are all servers basically to route all messages. So it's like this, this, this. Expand this. Them. Like that. Okay. Now, let me see the address space. How am I going to organize this? Could. Well, let's maybe later. I don't think I want to do it now. Okay. So, the address space. How am I going to do this? Well, there's 6 cables. Shut up. 6 cables. So, there is a lot of possible combinations. I can make an address by combining multiple cables. So all these wires, cables, wires, all these wires, they can lead out of there, right? So I can, and they're all the I/O expanders give the redstone signals a numerical value, which is every wire has its own value. Add those, you have a unique value. Well, I'll show you a table maybe sometime where it's explained how that works. But I can make unique identifiers by combining cables. So I think I'm going to do that. So I'm going to tell this thing, okay, farm. So that thing is called farm. Farm 5. So would mean farm, give me 5 stacks of wheat. Farm 5, okay, or farm wheat 5, something like that. And then this thing would go. There's a message farm. Okay. Okay. What's farm? Farm is green red. Okay. Green red goes on. This thing says, oh, green red, that's me. And then the message comes through 5. 5. Okay. That's one possibility. I think that's what I'm going to do. What I also could do is feed that information back. So, farm, green red. Oh, green red. 5. So, that would be a real DNS server, because he would be asking what is the address of farm. And he would say, oh, address of farm, green red. Oh, green red. send a message to green red. This over there. 5 wheat, something like that. Wheat 5. Anything. Okay. The problem, however, because of the limitations of these things, as I said, they're single core processors. You can only do one thing at one time. What I think I'm going to have to do is have it listen constantly. So turn it on, run it, boot it up, server started. What it does, it's looping, and constantly checking if its address is called for. If yes, then respond okay or something like that. What we could do is send its own signal back, so he would say, oh, he's listening, now I can send the message. He would be waiting for the message, etc. But it would have to be constantly looping and do nothing at the same time, which is a bit of a shame. But I think it's going to be possible to do. It's possible. But yeah, the shame I can't let it do multiple things at a time. So, because if you were in a network with multiple people, like this would be another person and this would be a person, and I want to send a message to him, which I think would be possible. So I would be that over there, this person Adam. No, Alice. This is Alice and Bob. Alice and Bob. Into security stuff here. Standard names, Alice and Bob, A and B. So Alice sends to Bob a message through this. But the problem is that Bob would be constantly have to wait. You see, he would constantly have to wait. Is there a message for me? But what if Bob wants to send a message? He can't because he's constantly waiting. That's a bit of a problem. So I think that would be solvable, but just hooking this up here. Just add a second one. Have them both access the same I/O expander. This one isn't constantly listening. This one is. So if a green red was this side, green red comes in. He said, "Oh, that's me. Ooh, what do you want?" And he would be doing nothing at all. He'd be doing nothing at all. If you want to send a message, you can access the same device. I hope. So I think that's all for today. For now, I'm gonna experiment a bit. Next time, I think I'm going to start to get the listening going. Then first kick this out. Just send a direct message because I know because there will only be 2 or 3 of them. You see, I can make a full message, which later. That's about the structure of the. Oh, this, by the way, is called Eve because he's evil. Alice, Bob, and Eve. Because in this situation, Eve would be able to listen to everything on this line, and well, yeah, it's a shame. Can't really secure it. Maybe I can secure it, but it's gonna be some other day. The problem is that every computer on this network will be able to listen to every other transaction or messaging over it. It's really safe, but hey, we're on a Minecraft server. Yeah, this is going to be some sort of an experiment, I guess. Going to be interesting. So next time, get the listening going and send a message on an address. Okay, fair goal, I think. I hope I wasn't too boring. Really hope so. I hope you're gonna watch some more of this. I've got a special Christmas present also ready, set up, which uses computers. It will use computers. Not yet. Gotta work on that. So, I will speak to you later. I hope, if you are still around and are not too bored about everything I am rambling about. Yeah.